Richard III had been dead for more than 5 centuries when scientists made a discovery that should have settled one of England's greatest historical mysteries forever. Instead, it created a new one. Beneath an ordinary parking lot in Leicester lay a skeleton that appeared to belong to the last English king killed in battle. The bones carried wounds matching medieval accounts. The spine curved dramatically. Even the grave itself told a story of a hurried burial after a devastating defeat. Everything pointed toward Richard III. But when researchers turned to DNA for the final confirmation, they uncovered something nobody had expected. A genetic clue suggesting that one of the most powerful royal dynasties in English history may have been hiding a secret for generations. The king had finally been found, yet history itself suddenly seemed far less certain. For centuries, Richard III existed as two completely different men. One belonged to history, the other belonged to legend. Historical records described a capable military commander who seized the throne during one of England's bloodiest dynastic struggles, the Wars of the Roses. But the legend was far darker. After Richard's death at the Battle of Bosworth in 1485, the victorious Tudor dynasty inherited not only his kingdom, but also the opportunity to shape his memory. Chroniclers writing under Tudor rule portrayed him as a cruel usurper, physically deformed and morally corrupt. Then William Shakespeare transformed that political image into one of literature's greatest villains, a twisted king with a monstrous body reflecting a monstrous soul. For generations, that version became more familiar than the historical figure himself. Yet there was a problem. Almost everything people believed about Richard depended on accounts written after his enemies had taken power. The man at the center of the story had vanished. His grave was lost. His body had disappeared. Without physical evidence, separating political propaganda from historical reality seemed almost impossible. The search for Richard began not with archaeologists, but with a question. If historical records consistently stated that Richard had been buried at the Greyfriars Monastery in Leicester, why had no trace of the church survived? Over the centuries, monasteries were dissolved, buildings demolished, and cities expanded. Streets shifted, property lines changed. Eventually, the supposed burial site became something entirely ordinary, a municipal parking lot surrounded by modern buildings. Many historians considered the search unrealistic. Centuries of urban development had buried medieval Leicester beneath layers of later construction. Even if the monastery could somehow be located, the chances of finding one specific skeleton seemed extraordinarily small. But historical maps suggested something remarkable. When researchers overlaid medieval plans onto the modern city, one small section of asphalt aligned almost perfectly with the long-lost monastery. In 2012, archaeologists broke through the pavement and began excavating. Almost immediately, they found human remains. The skeleton raised as many questions as it answered. The grave itself was surprisingly crude. It appeared too short for the body, forcing the head to tilt awkwardly forward. There was little evidence of the ceremonial burial expected for a king. Instead, everything suggested haste, almost as though those responsible wanted the burial completed quickly before moving on. Then investigators examined the bones. The skull carried devastating injuries inflicted around the time of death. Some wounds could only have been caused after the helmet had been removed. Others appeared consistent with weapons used during the Battle of Bosworth, where Richard was known to have died fighting. The pelvis also showed injuries that likely occurred after death, perhaps while the body was being publicly displayed following the battle. Each discovery strengthened the possibility that this was England's lost king. But one feature immediately attracted worldwide attention. The spine curved dramatically to one side. For centuries, Shakespeare's Richard III had been remembered as a grotesque hunchback, his twisted body serving as a symbol of inner corruption. At first glance, the skeleton seemed to support that image, yet closer examination revealed something far more interesting. The king did not have a hunchback. He had severe adolescent onset scoliosis. That distinction mattered enormously. Scoliosis can create a pronounced sideways curvature of the spine, causing one shoulder to sit noticeably higher than the other, while leaving the limbs proportionate and allowing an individual to remain physically active. Researchers concluded that Richard's condition would certainly have altered his appearance beneath clothing, but it would not have produced the dramatic deformity described by later writers, nor would it necessarily have prevented him from leading armies into battle. Suddenly, one of history's most enduring images began to unravel. If Tudor writers had exaggerated Richard's appearance, what else might they have exaggerated? The investigation was no longer simply about identifying a skeleton. It had become an opportunity to test centuries of political storytelling against physical evidence. Still, archaeology alone could never provide absolute certainty. Another king could, in theory, have suffered similar injuries. Another nobleman might have developed scoliosis. The investigation needed stronger evidence. That evidence came from genetics. Scientists extracted mitochondrial DNA from the skeleton. Unlike most DNA, mitochondrial DNA passes almost unchanged from mother to child through uninterrupted maternal lines. Because Richard himself left no surviving children, researchers traced the descendants of his sister through an unbroken female lineage stretching across more than 500 years. Eventually, they located a living descendant willing to provide a DNA sample. When the sequences were compared, they matched. The odds of such a match occurring by chance, combined with all the archaeological and historical evidence, strongly supported the conclusion that the skeleton truly belonged to Richard III. After centuries of uncertainty, England's lost king had finally been identified. The investigation appeared complete, but the scientists decided to examine something else. If mitochondrial DNA follows the maternal line, the Y chromosome follows the paternal line, passing from father to son across generations. In theory, Richard's Y chromosome should resemble that of documented male line descendants from the Plantagenet dynasty. Researchers located individuals whose genealogy traced through the accepted royal family tree. Then they compared the DNA. The expected match was missing. It was one of the most surprising results produced by the entire project. The mitochondrial evidence confirmed Richard's identity. The Y chromosome questioned the documented paternal genealogy. At first glance, the contradiction seemed impossible. How could both results exist simultaneously? The answer lies in how family trees are constructed. Historical genealogies rely on written records, legal documents, marriages, births, and inheritance. Genetics follows biological inheritance. Most of the time, those two systems align remarkably well. Occasionally, they do not. The missing Y chromosome match suggests that somewhere along the documented paternal lineage, at least one recorded father was not the biological father. That single event, sometimes called a false paternity event or non-paternity event, could have occurred in almost any generation, separating Richard III from the later descendants used in the comparison. And that is precisely the problem. The DNA cannot identify where it happened. It cannot identify who was involved. It cannot determine whether the break occurred before or after any particular king inherited the throne. The evidence establishes that somewhere in the recorded lineage, biology and documentation diverged. Nothing more. Yet that modest conclusion carries extraordinary historical implications. For centuries, royal legitimacy depended heavily upon bloodline. Dynasties fought wars over inheritance. Noble families defended carefully documented genealogies stretching back hundreds of years. Entire kingdoms changed rulers because of competing claims of descent. Now, modern genetics had quietly demonstrated that even one of Europe's most carefully recorded royal family trees contained at least one hidden uncertainty. Not fraud, not necessarily scandal, simply the reminder that medieval records, however meticulous, were created by people rather than by DNA. Predictably, speculation exploded. Some argued that the discovery undermined the legitimacy of later monarchs. Others claimed it vindicated Richard's political rivals. Still, others attempted to connect the DNA findings to one of England's greatest unsolved mysteries, the disappearance of the princes in the Tower. But this is where responsible history must separate evidence from imagination. The DNA says nothing about who murdered the princes. It does not identify any illegitimate king. It does not rewrite the Wars of the Roses. Those remain historical questions requiring independent evidence. The real discovery is both subtler and in many ways more profound. Science corrected several independent historical assumptions at once. Archaeology found the king where history suggested he should have been. Forensic anthropology revealed that his body had been misrepresented for centuries. Genetics confirmed his identity through his maternal ancestry, and a completely separate genetic analysis exposed an unexpected imperfection within the documented royal pedigree. None of those findings were the questions researchers originally set out to answer. Perhaps that is what makes the discovery so remarkable. History often advances not because investigators find what they expect, but because evidence forces them to ask better questions. The search for Richard III began as an effort to locate a missing king. It became an investigation into political propaganda. Then it evolved into one of the most compelling demonstrations of how archaeology, forensic science, and ancient DNA can work together to challenge narratives that had survived for more than 500 years. The skeleton beneath the parking lot did far more than identify a medieval monarch. It revealed that history is not carved permanently into stone or preserved perfectly in royal records. It survives as a conversation between documents, artifacts, bones, and now genetics. Each new piece of evidence has the power to confirm long-held beliefs, or quietly dismantle them. In the end, perhaps the most disturbing revelation was never that a royal bloodline contained an unexpected break. It was the realization that centuries of certainty had rested on assumptions no one had been able to test. The moment Richard III's DNA finally gave history an answer, it also reminded us that the past still holds secrets capable of reshaping everything we think we know.